In this video, we're going to calibrate and evaluate the inside measurement accuracy of three different sets of calipers. Instead of trusting a single tool, we're going to establish a reference using multiple instruments, because in metrology, agreement between instruments is how you build confidence. For this test, I'm using a set of telescoping bore gauges for transferring inside diameters, a Mitutoyo quantum mic micrometer mounted in a micrometer vise, three sets of calipers, SPI, Starrett, and Mitutoyo, a Hexagon practice part for metrology training, measurement philosophy. None of these tools live in isolation. The more instruments you measure with, the better, because what you want is repeatability and agreement. When independent tools converge on the same dimension, that's when you can trust the number. We'll work one hole at a time to avoid mixing data or biasing results. This is our first encounter with transfer measurement. Transfer measurement is an indirect measurement method. You are not reading the size of the hole directly. Instead, you transfer the internal dimension of a feature into a mechanical intermediary, the telescoping bore gauge. Transfer that captured size to a high-resolution reference instrument, the micrometer. Interpret the result based on repeatability and agreement across trials. The bore gauge has no scale. Its only function is to faithfully duplicate the internal distance between two opposing surfaces. This is fundamentally different from calipers or inside micrometers, which attempt to measure and display the dimension in one step. Why telescoping gauges exist at all? Telescoping bore gauges solve three problems inherent to internal measurement. Accessibility. Holes are recessed, shadowed, and often chamfered. Alignment sensitivity. Small angular errors produce large diameter errors. Resolution limits. Caliper inside jaws are blunt, flexible, and low resolution. The telescoping gauge allows you to establish true diameter at the largest chord. We're going to use a telescopic bore gauge that measures holes with a minimum diameter of 12.7 millimeters and a maximum diameter of 22 millimeters, as pictured, or 1/2 inch to 3/4 inch. Step 1. Fully compress and lock the telescoping rods. Begin by pushing the telescoping rods inward, fully compressing the internal spring. While holding the rods fully compressed, turn the locking screw clockwise. This locks the rods in their minimum length position, preventing any accidental expansion as the gauge is inserted into the hole. Step 2. Insert the gauge into the hole. Insert the locked bore gauge into the hole, positioning it approximately at the depth where the diameter is to be measured. At this stage, the handle should be roughly perpendicular to the hole axis, giving you clearance to work. Step 3. Release the spring to expand the rods. Once the gauge is inside the hole, slowly turn the locking screw counterclockwise. This releases the internal spring, allowing the telescoping rods to expand outward until they make light pressure contact with the internal surface of the hole. Step 4. The critical rocking motion. Why this matters. Now comes the most critical step, the rocking motion. With the rods expanded, tilt, or translate, the handle approximately 45 degrees away from being parallel to the hole axis, in the same plane as the telescoping rods. Then slowly rock the handle back toward a position where it is parallel with the hole axis. Explanation of the rocking motion. This rocking motion is not optional. It is essential. As the gauge is rocked, the telescoping rods pass through the true maximum diameter of the hole. At the exact point where the handle becomes parallel to the hole axis, the rods are momentarily aligned with the true diameter, not a chord or angled measurement. If you do not rock the gauge, you risk locking in a dimension that is undersized, caused by measuring across a diagonal rather than the true diameter. Step 5. Lock the gauge at true diameter. When the handle is parallel to the hole axis and resistance feels even on both rods, tighten the locking screw. This locks the telescoping rods in the position that most accurately represents the hole diameter. Step 6. Withdraw the gauge and verify capture. Carefully withdraw the bore gauge straight out of the hole. You should feel light, even drag as the rods are pulled free. This friction is a good sign. It indicates that the rods were in firm contact with the hole walls and that the dimension was properly captured. Excessive drag suggests too much pressure. No drag at all suggests an undersized or unstable capture. Step 7. Prepare for micrometer measurement. The bore gauge is now set and ready to be measured with a micrometer. Do not adjust the locking screw, do not touch the rods. Transfer the gauge directly to the micrometer and measure across the telescoping ends using consistent, light micrometer pressure. The bore gauge measurement turned out to be 17.900 millimeters as pictured below. So it is most likely that the hole diameter is 18 millimeters. Now that we have a reference measurement, we will use the calipers for inside measurements of this hole in the next video. Sure,